Thank you everyone so much for joining today. My job in the next 30, 40 minutes or so is to provide an update on ResFrac. What have we done over the past year? What are we doing over the next 1 year? And then also I'm just going to kind of remind you guys what our company is and what our purpose is. So here's our purpose. Our purpose is to help you optimize rate of return. So we want to help you make better decisions and shorten the learning curve. And I think now that we have a low price environment, which we had for a while, and now we have an even lower price environment, that's even more important because you need to eke out efficiencies to achieve tech profitability. And I would also note that when prices change, the price of oil or gas change, and also the price of inputs like proppant or even leasing, that results in a re-optimization because the optimal frac design, the optimal well spacing, those change as you change economic inputs. And so you need to know, hey, if we changed our well spacing, our cluster spacing, if we dropped proppant volume, if we increased proppant volume, et cetera, how is that going to impact my production? And that's how you can maximize your return on investment, which is, again, really what we exist to help you do. So ResFrac is a physics-based engine. That means we have taken this huge array of physical processes that occur during hydraulic fracturing and production in shale, and there's a lot, and we have tried to represent all of that into a single integrated self-consistent model. That helps us understand why things happen and what's happening. Form a hypothesis, test it, you learn from that, and you iterate. That application of engineering principles and scientific method is essentially how we have improved over decades to become quite good at producing from shale, although there's still plenty of opportunity to improve. And so we want to take that insight at asking why and then understanding and use it to optimize frac design in a quantitative way, such as determining specifically what we should do when we design a frac job practically. So that's what we help do. That's our purpose. And how do we do that? Again, first, we want to integrate data into a physics-based and internally self-consistent representation of reality. You're gathering all of this data, and it's quite diverse, and some of it's quite complicated. You're gathering microseismic, and you've got rate pressure data, you've got fiber optic, on and on and on. You want to take that, and you want to somehow synthesize it into a single description of what's happening. And that's what a numerical model like ResFrac is doing for you. It's taking a single thing, and it's encapsulating everything that you know into one thing. And also, it's internally self-consistent. The simulator is a logic machine. It's a computer that is designed to obey the laws of physics as we understand them. And so it tests your hypotheses. So often we think, oh, if this happens, then this will happen. And then the simulator surprises us. And you can pull up, these 3D images. You can make a movie. You can zoom in and out. You can visualize all these different things, and you can see what's happening. And you can answer these questions, why, and that allows you to really understand what's happening and optimize. Second point, solving practical problems requires an integration of complex and diverse physics. So I'm from academia originally, and in academia, we very often would get 100% best possible solutions to simplified problems in which we picked out just a little bit of the physics and we want to just totally get it right. And that's very useful. It's practically helpful in science and academia. But if we want to do practical engineering solutions, we can't leave things out. You can't optimize frac design, but leave out limited entry, right? And on and on and on. You can't optimize frac design without considering production, right? And so we have to put all of it together, and we think that's the best way to give you a practical answer. Third is continuous improvement is a big part of the culture of our company. Number one, in constantly engaging with field data. So we love to work closely with operators, and we are always trying to improve the model, make it better, make it more realistic, add in more things, so that we're always trying to represent physics, but also there's so much that we can't observe directly in oil and gas. Things happen 10,000 feet below the surface of the earth, and so we have to always think critically, and that's a big part of our culture. And second is feedback from users, because we in fact are making a piece of software that other people use. And so it's not just about getting the model right, but there's this huge challenge to try to make this thing usable. And we work very hard to streamline the user experience, and I'll talk about some of the improvements we made in the past year, and we're still working very hard on that. And really the philosophy is, on the one hand, we need to have a lot of advanced functionality because a lot of our users are power users. You're doing all this diverse set of things, And you need to be able to do that, but at the same time, we don't want to make this overwhelmingly complicated. And so that goes into the training and the way we design the user interface and validations and so on. So this is pretty much some of the key things that we prioritize as a company. This is our approach. I assume that most of you are familiar with the ResFrac simulator, so I will not belabor a description of the ResFrac simulator, but I will hit a few highlights. First, I want to emphasize that we are the only commercial simulator that is a true integration of a hydraulic fracturing simulator and reservoir simulator. And I have here a true hydraulic fracturing simulator purposefully because we mesh fractures as fractures. We simulate the propagation of cracks. This is not simply a reservoir simulator where we use a permeability multiplier to approximate kind of what a hydraulic fracture might look like in the rock. We actually model them as cracks. And I think I'll talk a little bit later. I'll just give an example of some really good data that's from the field that shows that these really are cracks. You know, we can see them in core and we can see them in fiber. And so I think it's very important to represent cracks as cracks. Second is this integration of so many different types of physics into one model, built on engagement with field data. So we're constantly trying to improve and learn from that. I used to think our user interface was a weakness, and now I think it's a strength. We've put just a ton of effort into that over the past year. We'll talk you guys through some of the improvements we've made, as well as things we're continuing to work on. And then the last one here, I think is really important, a detailed and public technical write-up. So there is no mystery about what physics this simulator solves. It is not a black box. And I think that's really fundamental, because I think if you're going to use a physics-based simulator, the point to me of using a physics-based simulator is to understand why things happen and to be able to articulate that in plain English and then use that insight to improve. And so if a physics-based simulator is a black box, then it is difficult to use it as it should be used. And so from the very beginning, I said it was very important for us to be totally transparent about what physics we solve. And so we do that. All right. Next, I am very excited to talk about the team. I'll discuss quickly some familiar faces, but also we have a lot of new people that have joined the company in the past year. So starting with myself, I'm Mark McClure. I'm co-founder and CEO of the company. I started the company not literally from a garage, but pretty much from a garage. I left University of Texas at the end of 2015 with the idea of writing this software, and it's grown from there. The other co-founder is Charles Kang, my old office mate from graduate school. He's the CTO, and he has really focused on the cloud operations side, integrating the user interface with the simulator, as well as just a million operational details that he's constantly on top of. That's the third key person, and I would also mention Soma met him. So Charles and Soma work very closely together. You guys have probably gotten emails from them. They are really partners in this project of making the user interface, getting everything to work on the cloud, getting it into corporate IT, and all of this, as well as what they're working on right now, which is automated decision support, which I'll talk about later. Garrett Fowler, our COO, he is right here. He's the triathlete, Ironman. Actually, we have several really outstanding athletes on the team. Dave Radcliffe and Yegor are also, and actually even Peter Gill. Well, anyway, we have a lot of good athletes on the team. I won't digress too much. Anyway, Garrett leads the client-facing part of the company. So you guys, I'm sure, have worked a lot with him. He kind of leads all the consulting work that's done and is in charge of kind of getting out the message about what we do. Been obviously done a tremendously good job, as you can see from the growth of the company. Then Dave Radcliffe, Matteo Picone, those two guys are consultants. They do a ton of consulting projects with you guys. A lot of you have worked with them. And then I'll also mention Peter Gill, financial controller down here. So those are the people who were with the company a year ago. We have some new people, starting with Joseph Yuyi. He is also on the consulting side. So he is got field experience running frac jobs in the field, then worked as a frac modeler for years, and we're very happy that he joined in the past year. Second, Chris Houston. He is a C++ and reservoir simulation expert. Very happy he's joined the team. He joined just a few months ago. You guys may have noticed the simulator has been running faster the past few months, and that is entirely Chris's doing. And very excited to have him on the team. Have for quite a while needed some really good help on C++ coding, and I'm glad we finally got someone in that role who I think is really great. So very thankful Chris is there. And then next I want to mention Yegor Dontsov. He joined just about 3 weeks ago. I am thrilled that he joined the company. I've known Yegor for many years. I first learned about him when he was a postdoc with Anthony Pierce Then he was on the faculty at University of Houston. He worked for Von Gunten for several years. And I am a huge fan of his work. He is an expert on the physics of how hydraulic fractures propagate, and also, very importantly, on numerical methods for hydraulic fracture propagation. So I'm going to talk a little bit more about some of the stuff that he's doing, but his really unique and outstanding technical expertise in the future is going to leave a big footprint on what we do. Next is Joe Franz. He joined as a senior executive advisor. Here's Joe with his family right here. And Joe has had a cool career. He most recently was an executive with Range Resources. So he's worked on the operator side for many years, but he's also worked on the service side for many years as a consultant, as a part of Steve Holich's consulting group in the 90s. So he has really brought a really cool experience to the team. Mark Zobak joined earlier this year as another senior executive advisor. Mark is a world-renowned expert on geomechanics, geophysics, really a diversity of different things, actually. And he's been an important mentor for me for a long time. I've known him since I was an undergrad, and I took his class, and we've worked together for many years, and I'm really thrilled that he's adding his voice to the Brain Trust. And lastly, but not least, I'll mention Tristan Lawrence, who has been doing a ton of admin and marketing work and has just made everybody's lives a million times easier. And so anyway, that's the team. We've built a really outstanding team, really excited to have all these great people put together, and it makes me feel really excited. I think about all the really wonderful people that we've put together on this team. Also, just want to mention another company update. We did raise a follow-on round of investment with Altera this year. So Altera first invested in us in 2018 and did a kind of a smaller follow-on investment earlier this year. So feel very honored to have that vote of confidence from them. And really that partnership that we've had with Altera has been a big part of our company's success. So that's Dirk McDermott, Sean Hebert, JP Bauman, and Abby Mercado. Abby subsequently has left to start her own company. And as a rookie entrepreneur, having this sort of professional oversight and guidance has been really critical for making sure that we have run this company the right way and that we have kind of had the right strategy. So just wanted to kind of mention that's another important thing that's happened in the past year. And definitely excited to continue that partnership. Recapping on our clients and basin play experience. So not all clients and users are public. We don't have permission to list everyone's name, but of the people whose names we have permission to list here is that list. And that covers, as you can see, a lot of different shale plays around the US. And also we've added Canadian and Argentinian projects and clients since 1 year ago. So the green ones here, Delaware, Haynesville, Montney, and Vaca Muerta, those are the plays that are added just in the past year. We weren't last year. So you can see that the company is continuing to grow, and I feel very fortunate that even in the past 4 or 5 months, we've continued to grow that list of customers, which is I think a mark of confidence in what the team is doing. Another way to look at this is a plot of cumulative ResFrac simulation hours. So it starts at 0 1 year ago. And you can see that there have been about 420,000 hours of ResFrac simulations run in the past year. So we are a great customer for Microsoft Azure's cloud server. But this shows just how much this stuff is getting used. And I'll also mention that there's been an uptick, as you can see here, and some companies have been going for these kind of unlimited use licenses. And what we see is when companies get unlimited use licenses, their hours of simulation time increases pretty dramatically. So I think that it's something that I certainly try to push everyone to do, because I think it really gives you the best way of using ResFrac when you don't have any limitation on how much you can run it. We've written a lot of papers in the past year. I won't go through all of these, but a few to highlight. I'm particularly excited about this work that we did with Hess and Craig Sapola, a Bakken case study, which I think he's going to talk about later and I'll mention later, so I won't go too far into it, but we've also done papers with Mark Zobak and Ankush Singh, Mark Pearson with Liberty. We have this paper that is just solely ResFrac internal people, nuances and frequently asked questions in field scale hydraulic fracture modeling. That's sort of the compendium of the 10 things people always ask about, and we put them all into one paper, as well as this cool paper that Garrett wrote on doing assisted history matching and RTA with ResFrac. All right, so next I want to just talk about some technical highlights. This is actually not an image of a ResFrac simulation, although we do simulate this. Just didn't have any public examples. This is a paper by Silixa, actually. And I just want to talk about how impressed I am with the quality of data that operators are coming to us with and that they have. So when you combine things like fiber optic, microseismic, interference testing, tracers, all these things, I think we're really getting an unprecedented look at where fractures are going and what they look like. I particularly like offset fiber because I like hard data, and you could see individual frac hits along offset wells. And I think that's just so, it really tells us about the key things that drive fracture growth. So if you have seen our recent training course, fracture toughness, leak off, and viscous pressure drop are the primary drivers of fracture geometry in terms of like symmetry, length, the rate of propagation, et cetera. And then also that integrates with maybe a few other highlights, limited entry, and the factors that affect height growth, which is like stress layering and effective toughness anisotropy. And so we actually really, I think, arrive at like very unique history matches. You know, I don't think that we suffer from a ton of non-uniqueness when we have this quality of data. And we see companies coming up with this. And I'll also mention that a lot of things can't be measured in the lab because they occur at a field scale in a way that's not the same as a tiny, you know, bench top experiment. And so you have to use field data to characterize some of the key inputs to ResFrac. But what's really cool is that with this quality of data that we're getting, companies are able to do that. And we can even try to get some pretty good ideas about where proppant goes and how conductive that proppant can be. We can look at things like interference testing and other sorts of experiments involving injection and production and comparison and flow between wells. And you can really start to figure out where the proppant went. And that's telling us about what drives proppant transport. You know, we see some cases where it looks like there's quite a lot of localized screenout, something that's been described in core through studies recently. And then others, it looks like there's less, right? And so we really are building this level of understanding because of the quality of the work that operators are doing. And also the service companies are like Silixa, for example, are doing a really good job of that. And so that's a really exciting thing to me. And that's a kind of a trend that I observe, just kind of looking out on what operators are doing. You know, I think one thing I like about this strain measurement here in the fiber is you can see there's two tensional lobes and then the crack hits. So that's illustrated in the Silixa figure where, and this is similar to something that you might have simulated in ResFrac. Ahead of the crack tip, there's tension, and along the sides, there's compression, and there's two lobes ahead of the crack tip. That's exactly what the analytical solution for the stress and strain field around a crack is supposed to look like. That analytical solution's, you know, over 100 years old. And when you look at strain measurements of fracs approaching offset wells, that's exactly what it looks like. And I think it's just a huge win for theory that a mathematician many, many years ago derived what the equations for the stress field around a crack is supposed to look like. And then here we are looking at it in the rock with fiber, and we're seeing that exact signal. And that's really remarkable, and it shows the power of a physics-based approach to predict things. Certainly 100 years ago, they didn't know anything about hydraulic fracturing, but their predictions have borne out. And also, it just does in fact show that these are cracks propagating through the rock. In case there was any doubt about it, they behave exactly like they're supposed to behave if they're cracks. Secondly, I think Craig is going to talk about this, but just want to mention this paper. This is a really complex data set that Hess developed. It's a parent well in the Bakken that produced for 10 years, and then there's two offset vertical wells. There's a series of injections performed. They did some DFITs in the wells. They did a frac job in one of the vertical wells. They re-injected into the parent well. There's poroelastic, there's frac hit. So there's all these different things happening. Done in this paper that we'll present at ATCE is that we were able to set up a ResFrac model that simulates the whole thing start to finish. So the poroelastic stress change, things like the DFIT responses, and the DFIT responses change dramatically over time. So there's like repeated DFITs in one of the wells, and they look really different. And that's because of the things that have happened from the first DFIT to the second. We can look at things like the pressure response in the parent well when it's injected into, and then when it experiences a frac hit. And then ultimately, the parent well saw, in this case, a production uplift, and we can model that too. And so there's a lot that we learn here, which is described in the paper about effective prop length in the Bakken, proppant transport in the Bakken, BO coefficient, and the power is that once you have learned these things, then that impacts how you might design your development in the Bakken and your well spacing and your proppant schedule and so on. So this is another really cool example. And the third one I'll mention is I really think the case for planar fracture modeling continues to strengthen thanks to work that's being done, by a variety of operators out in the industry. So this is a talk I gave for the American Rock Mechanics Association. They were doing weekly talks throughout the summer. And so I gave one called The Case for Planar Fracture Modeling and talked about all the different lines of data that show that, in fact, hydraulic fracturing does look like a bunch of mostly subparallel fractures all directed in the same direction. And they can be modeled as planar fractures. The planar fracture model is not a perfect representation of what's happening. There's small scale complexity, and we capture those sorts of small scale complexities with constitutive relations. You know, if a fracture jogs over 6 inches and some proppant gets trapped in that jog, we need to consider the fact that proppant might get trapped, but we're not going to run a field scale reservoir simulation, frac simulation model that has 6-inch jogs, right? So we have to kind of balance that, and that's how we do it. So I think that just as more and more data comes out from operators, I think that it's really the whole industry is realizing that, you know, planar fracture modeling is the classical and remains the right way to go on frac modeling. All right, so I want to shift gears and talk about the new user interface. So 1 year ago, this was a glimmer in my eye, and now it's fully operational, and I'm quite happy with its reliability and performance and so forth. So when you open up ResFrac, this is the ResFrac Job Manager. Just a list of simulations. Within that list, I can have projects. Within a project, I can have folders we call workflows, and then within the folders, I have simulations. So it helps you keep things organized, and this is kind of what it looks like when you open up the application. Here's the visualization tool. Compared to last year, it opens way faster. So the old visualization tool used to take too long to open, and I found it annoying. So this one is snappy. No matter how complicated your simulation is, it should open up right away. And all this customizability around how many visualization panels you have, what you're going to show, what you want to, do you want to cut a slice of the matrix? Do you want to show the matrix? Do you want to show the wells? Plotting tools are much improved. You can customize things like the size of the font. You can have a whole bunch. You can have as many y-axes as you want, or maybe like up to 6 or something. I don't remember. And so a lot of just optionality. We've really custom built this visualization tool to be exactly what you need to visualize ResFrac simulations. It's very intuitive and easy to use. So very happy with what we've been able to do here. And also, of course, you can save these visualizations as layout so that you could open it up just like this a little bit later, and it would look exactly the same. That makes, of course, it easier to kind of streamline your workflow. This is the simulation builder. As you can see, it's fully redesigned from the old style simulation builder. In function, it's the same. You start at the top, you go down panels, and you input all the things you need to input to set up a simulation. Here are some of the special features that I like and that we have added. First, we've added a lot of wizards. So wizards will automate parts of the process for you. So for example, it would be ideal if you have a black well table that you've already built, but if you do not, we can set one up for you using correlations, and you input things like reservoir temperature and GOR, and it will generate a black well table. So we put in a lot of wizards like that to facilitate things that are required for setting up a simulation, things like importing a wellbore survey, etc. Secondly, we have much better built-in help content. So you can see here, if I click on the help icon, I can pull up help. We have integrated movies, and in fact, Garrett just filmed a bunch more, so we're about to put a lot more movies into the UI. You can put in equations and images, so the help content, which is built in, is much improved. Another thing is you can preview things. So let's, for example, down here on the bottom left, this is after we've inputted the black oil table. Now it actually is going to generate a plot of oil formation volume factor, gas formation volume factor, solution gas well ratio, those things versus pressure. And so you can actually visualize what you've inputted. It's a good way to validate that it's doing what you think it's doing. And also, very usefully, you can make a 3D preview. So as you're inputting things like well geometry or the mesh, obviously it's kind of hard to just in your mind imagine what that looks like as you're inputting the data. So now you can press a button, you can put up a 3D view, and you can just visually look at what you're setting up as you set it up. That's been a huge help. The validators are still there. We've continued to improve them. I'm constantly adding more validators. So if you punch in numbers that are impossible, you'll get an error. If you punch in numbers that might be wrong, but maybe they're right, we're not sure, we'll give you a warning and ask you to check. And so that's designed to help set up these simulations. So you should never run a simulation, submit it, and it runs and then crashes because you input a number that's impossible, because it would have been caught in this validation step. And I think as somebody who used reservoir simulation software for many years, having validations like this is just so important. And my attitude is, anytime anybody ever emails me and they're confused by an input, then I put in a validator. So even if they put in a number and it's easy for me to say, well, you shouldn't have done that. But if they were confused, then it's the fault of the UI that we didn't make it easy for them. And so if we ever get a simulation that's set up with an issue, I put in a validator. And my attitude is it should be easy to set up simulations. And so I really want to minimize issues, and that's what that's all about. From the old UI, we've dramatically improved and streamlined how you specify pump schedules and production sequences. The old way was pretty clunky, and now it's a lot easier. It's just a table input. And also a nice thing here is you can now search. So you can type in the name of a parameter, and it'll find that parameter in the UI. And I go through this stuff because I think I notice a lot of users aren't even aware of all the features. So you might be a longtime user and not have known about everything I just said, like the search function. A lot of people don't notice it. Another thing that we've rolled out just in the past few months is a command line user interface. So if you are a power user, you could, for example, you might want to run a Python script that could programmatically set up a bunch of ResFrac simulations, run them, download them, and analyze them all yourself. So that is now very easy to do with this command line interface that Soma put together. This allows you to submit jobs, you can download them, you can check on their status. It even has the ability to run the validators before you submit them. I'll note that all of the input files to ResFrac are just text files, so that's something that's easy for like a Python script to modify. So that facilitates this sort of scripting, as well as the output files. We provide a binary format that is quick to read for our visualization tool, and then we also provide a text format that is human readable. So we want to facilitate this sort of power use, and several companies have been asking about this, and so I'm very excited that we've just very recently rolled this out, and I hope that we get more users on this because it's very powerful, and it would integrate with other things. Like if you have your own automated history matching tool, I know a lot of big companies have that, this command line interface makes it really easy to do that. All right, next is training. So I think we've done a better job of putting together training content, and I think Garrett gets huge credit for that. He's done a really good job of putting together some great training content. So this is from an in-person training event that we did pre-COVID, and day one I did kind of some technical background. So I went through the conceptual approach of how we represent fractures and why in ResFrac, things that affect fracture geometry, physical processes, and the numerical approach. So that's day one. And then the next 2 days, Garrett really just went through all the nuts and bolts, step by step, setting up a simulation, visualizing, and actually doing a worked example of a history match. So we then wanted to keep doing trainings. We couldn't continue to do them in person, of course. So we more recently did an online training course, which was very well attended. We had hundreds of, I don't know exactly, over 200 people attended, which was really cool. And that entire course actually is now posted on our website. So it's available to anyone to review. Again, day one is kind of general technical background, and then days 2 and 3 are specifically how to use the software. So we're working hard to keep improving training, as well as, of course, we are always very committed to working closely with users and making sure you guys have a lot of support. So we are always happy to talk to you guys on the phone or email or whatever, and thank you guys for continuing to reach out, and don't stop doing that. Of course, we continue to always try to improve the simulator. It keeps getting faster and faster, and that work is not finished. There's still plenty more obvious things we can do to make the simulator run a lot faster. So we're continuing to work through all of that. In addition, there's just a million little refinements that are necessary. So I'll just give an example here. Let's say the user has inputted a different bottom hole pressure every 5 days as the well is put on production. Well, in the old setup, every 5 days, bottom hole pressure would abruptly change. So when you get that, you get this stair-stepping bottom hole pressure. The result is every time you do that, you get a weird spike or anomaly in the production rates. So I put in a linear interpolator, and I very recently, as of like this week, putting in a spline interpolation so that this bottom hole pressure sequence can be made smooth. So if we look at this orange line here, it's coming down, it's smoothly coming up and down. And so now the user can put in stair-stepping bottom hole pressures, but we won't get these weird artifacts, and we'll get smooth production rates. So that's just one of a billion things that we have to get right. And so we're constantly trying to improve these details. Users, you're great at giving us good suggestions. And so it's not just about the big picture, but it's about all these little details. And so that's an example of many of the kinds of things that we do. Some other things we've put in the past year, you can now rotate the simulation grid to align with stresses. That actually has done a lot to make it easier to set up simulations. Put in a modified black oil approach. As shown here in this, actually I worked with Whitson on that a little bit, and so we have a blog post about that, and here's a screenshot from their blog posts. You can do things like you could actually drill a new well in a restart file, which you couldn't do a year ago. Those are just a few examples of the many, many things that we continue to do, and you guys might have noticed we roll out an update about once a month, both to the UI and to the simulator. Current development themes, in addition to those little millions of little things that we are always trying to improve, here are some of the key things. Number one, corner point gridding importing support is overdue. I wish it was already here. Frustrated it hasn't come out yet, but it is finally here. I've been able to finally. Chris is finished with his work on speeding up the code, and he is now fully all guns firing on implementing corner point. And so I expect that to roll out within a few months. Next, I want to talk about what Yegor is starting to work with us on. There is an algorithm called the implicit level set method, and it smooths out fracture propagation. So right now, when a fracture extends in ResFrac, it adds a new element, and that's actually numerically inefficient because when it adds a new element, fluid kind of rushes into that element, causes a bunch of extra time stepping to happen, and so it kind of slows down the whole thing. It also impacts accuracy or resolution. So the implicit level set method essentially is another sub-meshing. You might note there's a lot of sub-meshing in ResFrac. And so what happens here is you can have these rectangular elements, but the crack front is not necessarily at the edges of the elements. We can kind of understand that only parts of elements exist at any given time. That allows fractures to grow gradually. And so that's what Yegor happens to know a lot about, and he's going to be implementing that in ResFrac. That's going to improve performance. It's going to speed it up. It's also going to improve, numerical accuracy on the fracture propagation problem, as well as, and often we've been recently getting the request, can you resolve really fine beds? If I have a 1 foot thick layer of a different type of rock, how does that impact height growth? And with an implicit level set approach, we'll be able to solve problems like that with great accuracy. So that's Yegor's kind of first project. And then the next thing is that we'll think even more broadly about that technique and how can we extend that out even further to speed up the entire frac propagation model entirely. And so that's initially going to be on accuracy and performance, and then it's going to move to a more radical change in how we model the fractures to try to dramatically accelerate runtimes. So, and then of course there's not just a million refinements, but there's also just some bread and butter computer science changes we're continuing to roll out kind of continuously on making the code run faster. Last big development push is on automated sensitivity analysis. I hoped it would be ready by this time. This year it didn't, and I think that's because the UI work took longer than I would have liked, but the UI work, I'm finally happy with it, and now we've got all guns firing on the decision support stuff. So we've got Charles, Soma, and then a team of UI contractors with an external organization implementing this right now, and they're really just kind of midstream putting this together. And so point one is automating sensitivity analysis and integrate it into the graphical user interface. So you go into the builder, you can select properties, you can say, I want to add this to a sensitivity analysis, and then the program generates a whole bunch of simulations, runs them all on the cloud, downloads the results, and then post-processes them to create things like in this case, it's like cross plots or tornado charts and things like that. So that's sensitivity analysis. That kind of first step in this decision support, I expect to be released before the end of the year. And then next year, early months of next year, the automated history matching and optimization will be coming out. So that would be where you say, here's the data that I want to match. Here are the inputs that I want to change, whether it's permeability or fracture toughness or whatever. And then the algorithm will find the combination of parameters that matches the data. And then finally, the last step there is an optimization. You might say, hey, I'm willing to consider changes to my proppant loading, my well spacing, my fluid volume, and then it will run an optimization algorithm on your history match model and spit back and say, this is the best design that we were able to find. So very excited for this to roll out. And finally, because we've cleared the deck and we've gotten the UI work done and we're kind of happy with that, it's delivered, we've been able to finally focus our development firepower fully on this. So very excited about these improvements. As you can see, there's a lot of big things coming out on the technical product side in the next year, as well as continuing all the exciting technical work that we're doing. Okay, that is all I had to say. I went longer than I expected, but I think we still have maybe time for questions.
Yes, we have about 10 minutes for questions. ResFrac folks are monitoring the chat channel. You can also raise your hand. I'm watching the participant list. If you all have any questions, let us know. I see a couple. Mark, can you comment on bug list and quality control processes around software testing?
Yeah. So before we push a simulator update out to users, we have a validation suite. So there's a set of problems that the simulator has to solve, and it checks whether, of course, the simulator successfully solved all those problems, and then also checks to see whether it got the right answer. Some of those, or actually a lot of those problems, are kind of just complicated ResFrac simulations where there's not sort of some known analytic solution. And so there, what we check for is consistency. In other words, has the result changed from the last time that we ran this code? And that's part of the process when we roll out simulations. I don't know if the question is noted by, we've had an unusually high number of simulation failures the past probably 6 weeks. And what happened there is we pushed out the faster solver, and then the faster solver, number one, led people to start running bigger simulations, and we started seeing things like computers running out of RAM. Also, the solver itself had some more bugs than I expected. So the last couple of weeks have been a little bit frustrating because it's been a higher error rate than I like. But yeah, that's the process. Is we have that validation suite, and basically, if we do get a simulation that fails or has an issue, we try to prioritize that, because that's an important part of our commitment to you guys, is to make sure that the simulator always is working smoothly. So that's pretty much, me or Chris, drop what we're doing and try to fix things. And that's an important part of it. I don't think we can get the error rate to 0, and that's because, there's a literally infinite number of different ways someone might run a simulation, and I can't test every possible combination, and so there will occasionally be issues. But our commitment is to work really hard to get those resolved as quickly as possible, and then make sure that the error rate is low.
Thanks, Mark. Follow-up question that relates to some of the features you highlighted that Chris and Jaegor are working on. Can you maybe comment in more detail about including geologic variability, as well as multiple wells and full well scale simulations? So
yeah, well, so including geologic variability is something you can do right now. Here, I've got the UI up. If you go to the static model, this button here that says use general heterogeneity allows you to select a file, and you can specify almost any of the properties here in this properties versus depth table. You can specify on an element by element basis in the simulator. So that's something you can do right now. And so, yeah, that's something you can do now. Corner point gridding, you might want to do the same thing, and that really won't be any different. You will just be specifying properties on an element by element basis in a corner point grid instead of a rectilinear grid. Running full well length simulations. So that's, I have always said, and I still feel quite strongly, that it's more important to have all the physics than to just like run a big thing. And if we run a simulation with 10 stages versus 5 stages versus 3 or versus 50, are you going to get a different answer? And you're probably not going to get a different answer. We're trying to optimize typically around, future wells. How are we going to frac the next wells over the next 6 months? And so overfitting to the detailed geology of like a particular pad is great for matching that data, but then that doesn't really tell you about the next pad that's a little bit different. So that's been our philosophy. Having said that, there's certainly applications where modeling full wells is useful, and certainly that would be nice. So that's really, I think the idea here is where we're talking about using this faster running and more approximate frac propagation model. So you guys, if you've used it, you might notice that as the number of fracture elements increases, runtime increases a lot. And so I think the solution is to basically reduce the number of fracture elements. Can we represent fractures in a way that instead of basically not using like a 3D gridded fracture, but without sacrificing on the ability to capture detailed fracture geometries? I don't want to use a pseudo 3D model. I don't think that's close to adequate for shale fracturing, but can you do something where you're more efficiently meshing the fractures? So that's what this is all about. And so this is pretty much the challenge that I've given Jaegor, and he just joined 3 weeks ago. So I think we've really got somebody who I think is a world expert on the subject, who's going to come in here. And what's important is integrating all of that in with all the features of ResFrac and all the other capabilities, which is cool. So all the user interface and all the multi-phase flow and all the other stuff the code can do, if we can drop sort of this kind of space age frac simulation inside of that, then we'll kind of have the best of all worlds.
Great. And then a quick one, does the interpolate BHP control, do you anticipate that having any impact on runtime?
Oh yeah, it speeds up the runtime a lot. Actually, the update that we're doing like this week has several things around that. So like, for example, one thing I've noticed is users, you might specify like a different bottom hole pressure every 2 weeks, but if you have 10 wells and they're not all aligned, then what you end up doing is you end up specifying a different bottom hole pressure like once a day, right? Because you like first day is well A, second day is well B, third day is well C, etc. So in the new update that's coming out this week, for example, there's a checkbox where it will automatically detect that and align boundary condition changes so that you don't end up with like this really, really high frequency of boundary condition changes, which slows down the production part of the simulation. So basically, if you specified everything aligned every 3 months, then it would just rip through the production period. But what we see sometimes is users specifying production constraints at higher frequencies, and then the wells get offset, and then it just dramatically increases runtime. So that's exactly what this week's update is around improving. And it's an example of all these little refinements that you've got to work through to make all this work.
Great. To the person who asked about ResFrac Lite, the fast approximate fracture model that Yegor is going to start working on is what we were previously calling ResFrac Lite or ResFrac Turbo.
Yeah, and on that ResFrac Lite thing, I think one of the lessons for me is that I have a million things coming into my plate all the time, and so we can't rely on me to do everything. So that's why we brought in somebody else, Yegor, who's really an expert in the area and is going to be able to focus all of his time just on that. So I think that's going to yield some really good progress, and so that's why I am actually very optimistic about our ability to roll out that improvement. Not in the next 3 months, but in the next year. Okay, thank you everybody. Appreciate your joining.